you're seeing here, right? This person is from the Geological Survey of India, from Dehradun, who was there in our team, right? So that means we should do science in Antarctica, which should be able to solve some global problem. So now we already know that there is a ozone hole in Antarctica. We also know that the ozone hole is created by chlorofluorocarbons, but I posed a general problem question to you that we all, as chemists, we know that it is chlorofluorocarbons. But in Antarctica, we don't release any chlorofluorocarbons. We never made any chlorofluorocarbons in Antarctica. Then why there is no ozone hole over US? Why there is no ozone hole over China or India? Ozone hole is over India. That tells that about the whole of the world is united. Nature is united. And the picture here shows this is my experimental stuff, my research stuff, which I need to take to my station from the ship. I'm sitting inside. This is how your luggage is transported. You will get another picture where this all this luggage, which is in the sling now, that will be on the deck of the ship. So why there is hole, ozone hole is over Antarctica when there is no human activity? To understand it, we need to understand the structure of the atmosphere. You see, our atmosphere is divided into several layers, like you see the troposphere, stratosphere, mesosphere, thermosphere. And our habitat is situated in the troposphere. So troposphere is the layer which is closest to us. Fortunately, you see in like a place like Merida, you see the weather is, the sky is so clear. Yesterday, my son and my daughter is not here, but son is here. So they were talking. He said, "Oh, there is some scam." They were joking. "Oh, the sky is so blue. You see, it's difficult to see such a blue sky." So he was mentioning, "Oh, we saw such kind of sky either in Europe or US, and I'm seeing it after such a long time in India." Right? So we are lucky to be here. That the weather, AQI even today also is in a good category. But it seems like the troposphere is endless. So when we look up, as long as we can see, that is troposphere. So it looks like it is endless, but it's the thinnest layer, almost about 10 or 11 kilometers. And it is the layer in which whole of the atmospheric chemistry takes place. 99% of the atmospheric chemistry takes place. Cloud formation is in this. So the weather patterns, they are because of this troposphere. So it's a very, very thin layer. Only about 10 to 11 kilometers on an average, otherwise 7 to 17 kilometers is the difference. And so that's a very thin layer, but 90% of the atmospheric oxygen or 90% of the atmosphere is in this layer. Right? And to understand, we need to understand what is the temperature variation in troposphere. So in the troposphere, as we move up, the temperature keeps on dropping. That is why you see when you fly by an aeroplane, sometimes you see that there are ice cubicles outside your window. So why? Because the temperature, the temperature outside your aeroplane window, it can go up to minus 40, minus 50 degrees Celsius at that heights. Right? So what happens that in the troposphere, the temperature keeps on decreasing. The average temperature at the surface is, let us say, 15 degree, plus 15. So it keeps on decreasing till it reaches about minus 50. So what is the impact? The impact is that because as you go up, the temperature is decreasing. So that means if hot air starts from the ground, then as long as the air around it is colder, it will keep on rising. But there comes a particular point in the atmosphere, that is the junction of the stratosphere and the troposphere, where the temperature stops to decrease. The temperature profile again changes. So from plus 50, minus 50, now it starts to again go higher. So minus 40, minus 30, so it will again starts to increase. So there is this junction between troposphere and stratosphere, what we call as the tropopause, or we also call it as cold trap. Why it is a cold trap? Because suddenly at a height, at the junction of troposphere and stratosphere, now the air is no longer cooler. So if the air is no longer cooler, as I said, that as long as the air around you is colder, the warm air would keep on rising. But now when there is no further decrease in temperature, what will happen? So now the air which is going above, it cannot go further. So what happens at that stage? It starts to diffuse horizontally. Because because now the temperature is above temperature is higher, right? And the simplest, oversimplified way to understand it, that sometimes if you are traveling, let us say on a very calm day, on a highway, so you suddenly see that there is some chimney which is emitting black smoke. So you would see that if it is not, the air is not there, wind is not there, you would see that a column of smoke, you can very clearly see that it is rising as a column, as if it is it's a chimney. But suddenly you see at some height, it stops. You can't see that it's going up. So suddenly you see it diffuses now all around. Why? That tells us that there is the temperature inversion. That is the cold trap. So it's going up, and at one stage, now the upper atmosphere is not further colder, it is warmer. So now it cannot go further. So it starts to diffuse sideways, to diffuse horizontally. Right? And that is, this phenomenon is very important. So that means whatever we are emitting in Nainital, it is reaching that tropopause, and once it reaches that cold trap tropopause, after that it starts to diffuse horizontally. Imagine that we release something unique which we have never seen in the troposphere. Imagine that there is a new chemical that we released on an experimental basis. So what will happen? That chemical will keep on rising, if it is a gaseous. It will keep on rising till it reaches the tropopause, and after that it will diffuse. And you will see that if after 5 days, if after 10 days there is a rain, we may find the same chemical in Delhi, or in Kerala, or in Assam, or in Jammu and Kashmir. How did it reach there? Because of that tropopause, because of that cold trap. So because now it will start to diffuse horizontally. And the same thing happens with all chemicals. Now, we say 90% of the atmosphere is in the troposphere. So, what is the composition of that atmosphere? You see, the composition of atmosphere is a few dominant gases, like 78% nitrogen, 21% oxygen. So, 99% is accounted for. Rest is 1%. So, 1% is all other gases. Within that all other gases, also around 0.9% is only argon. So, that means only 0.05 to 0.1% is the all other trace gases. And when we live in a democracy, so sometimes we think that the majority is always the authority. No, the majority is not always the authority. So all those things which are less than 1%, of course, we cannot survive without this 21%, which is still not a majority. Majority is nitrogen. But these less than 1%, they control most of the weather. Most of the chemistry is controlled by these 0.05 to 0.1% of the gases. So, other than you see, this is the composition of the dry air, but other than you see the nitrogen, oxygen, and argon, there are the particles, particulate matter, there are water vapor, and there are trace gases. And there are many trace gases, but few trace gases which to chemists are very important are like carbon dioxide. So carbon dioxide today is about 418 ppm. Right? 418 parts per billion. Methane 1.9 parts per billion. Look at ozone. We are talking about ozone today. 50 parts per billion. 50 parts per billion. That means less than one ozone molecule for every 1 million molecules of air. That if we have 1 million air molecules, I don't have even one molecule of ozone. And we are talking about ozone hole. So, if in mathematics, many times we say, oh, this is infinitely small, so it is insignificant, we can ignore. No, in nature we cannot ignore. We cannot term anything which is insignificant. Trust me, it is my personal thought. If anything which is insignificant in nature, that is only human. If we cease to exist on this planet, nature would flourish like it. We have seen its example during COVID-19. Right? So, other than human being, there is nothing in this planet Earth. The smallest of the insects to animals to like ozone, which is 50 parts per billion, that is not it holds great significance. So it's a rare gas. It's a very rare gas, very low concentration. And it is probably the most interesting and most contradictory gas in climate science. Most interesting and most contradictory. Why contradictory? And please remember that when I'm presenting this, you should have a different perspective also. That how to put the things in the right perspective. That is also, you can say, a cornerstone of a good teacher, a good professor. Right? So we say contradictory. Interesting. Why? Because if the same ozone is in troposphere, those of you, if any one of you has used in ozonolysis, so you see in ozonolysis we use an instrument to produce ozone. And the ozone that it produces is in ppm amount. But the protocol to use that ozone producer is so high that there has to be a special fume hood, not any fume hood, with that OSHA some guidelines. And then you have to have special kind of masks, right? And then still there have to be a supervision, so many conditions. So near Earth, it is a high